Hey guys, Andre from High Performance Academy. Welcome along to this week's live webinar. Today we're going to be talking about dry sump lubrication systems. We'll find out what a dry sump lubrication system is, why it offers us some advantages, and where those advantages lie. But before we get into that, just a bit of a recap on what's been going on since last week's webinar. Had a pretty big week last week. In particular, we had the second round of the South Island Endurance Racing Championships at our home track, Highlands Motorsport Park, on Friday and Saturday. So most of the end of last week involved preparing the black Toyota V8 86 for that round. In particular, we added a little bit of aero with a very basic ghetto diffuser at the front. Splitter at the front, diffuser at the rear. We haven't done the diffuser yet, that's still to come. So yeah, we built a ghetto plywood splitter at the front. We added a couple of canards. Now I'm saying we, but really I can't take any credit for any of this. This was all 100% Brandon's work, and he did a really good job. At the rear, we had a pretty limited amount of time to work with, so we added a very basic rear wing. So we weren't expecting miracles from this, but on track it actually really did turn out that it worked quite well. With aerodynamics, and of course I don't profess to be an aerodynamicist, but what basics I've picked up from talking to some really smart people, the likes of Andrew Brilliant, who designs the aero for a lot of the World Time Attack Challenge cards, just for one example, is that the aero obviously needs airflow over the wings, the splitters, etc. in order to start working. So of course we start seeing the aero effect become more prominent as the car goes faster. Not exactly rocket science here. So we're not expecting anything major from the slower corners in terms of our aero downforce. And in particular at our local racetrack, Highlands Motorsport Park, we do have a very long sweeping right-hander. It goes through just about 180 degrees back on itself, and we take that corner at around about 130, 135 kilometers an hour, which is fast enough to actually get the effect of that downforce. And in looking at our back-to-back data, just the addition of that splitter, the canards, and that basic rear wing, we're able to go through that corner around about 4 kilometers an hour faster. Doesn't sound like an eternity, but when you're in that corner for some in the region of 20 odd seconds, that is a bunch of time that we are picking up there. There is another section of the track which I'm going to show you a short video of how not to approach this section, but a very fast left-hander which we're approaching sort of somewhere around about 160 kilometers an hour, and we hadn't been able to get through that flat on the throttle previously. With the aero we were, so equated to a really big dramatic drop in our personal best lap times. Went from a previous best of 140, a minute 47.7 in qualifying for a race at the beginning of the year. In the race on the last lap I managed a minute 45.1, so 2 and a bit seconds. It's a pretty significant amount of time to drop. However, the race unfortunately was still a case of what could have been. On paper we had race pace to finish second in our class, which is for 3.5 litre and above. Class, I will mention that in some cases we are fairly squarely out of our league, given that we are only running a 4 litre engine. There's some pretty big capacity engines in there, some making much more power than us, so we were pretty happy with that. However, right from the formation lap when Ben left the pits, it was clear the race wasn't quite going to go our way, and we had our fuel pressure issues from the Teretonga round 2 weeks ago come back to bite us. I had seen a fuel pressure sensor warning or fuel pressure warning come up on the dash during my qualifying session. I didn't really think too much of it. This car does still run a factory fuel tank, and when we are low on fuel, it is prone to surge. Generally when we're down below about 15 litres, we will get some fuel pressure warnings come up on the dash. So we put it down to that, fueled the car, but as soon as Ben left the pits on the formation lap, he was back on the radio saying that he had some problems. So obviously not exactly what we wanted to hear. This is a rolling start, so we made the difficult call to actually pit Ben on the formation lap. This allowed us the time to work on the car, try and get a solution for that, and send him out of the pits. Of course, he'd be leaving at the back of the field, so we're kind of throwing away our chances there. I made the decision there to unplug the fuel pressure sensor, and it should have defaulted to 4 bar in the ECU, which should have fixed our issues. Left the pits, and it didn't turn out that it fixed it. In the meantime though, Brandon, as he was unplugging that, thought that he had figured out the issue with the whole problem. Just to give a bit of a recap, we have got a fuel pressure sensor mounted on the the end of the fuel rail. So we'll just jump across to my laptop screen for a moment. I'll just sort of show you the general layout in the engine bay. So this is our Honeywell fuel pressure sensor mounted on the end of the rail. Now, probably with all things considered, not the ideal place to be locating the sensor because it is prone to vibration that's going to be transferred through the engine into the sensor. And in particular, that's what we actually put our failure down to at Teretonga. At the Teretonga round, we had been chasing a really serious vibration that was a result of a poorly balanced drive shaft that we'd had made up. Between Teretonga and our Highlands round, we'd sent the drive shaft to another manufacturer. They'd tested it, found it was out of balance by 20 grams, rebalanced it, and that had proven to fix our vibration issues. So for all intents and purposes, we should have been okay. However, that wasn't the case. This time it wasn't the sensor that actually let us down, and instead it was this little connector for the sensor. For those who have wired any of these Honeywell pressure sensors, you'll know there's two connectors available. For some reason we ended up getting stuck with this one, which is one of my most hated connectors, and so much as you have to actually pull the wires through the connector body to start with, then you can crimp the terminals onto them, and then they pull back into the terminal body, the plastic body. On top of this, there should be a little grey locking plate that goes over the top of this. We think this is probably part of the issue. As you can see, I've pulled that out, and the little grey cap that should lock all of those terminals in place in the connector body there has actually remained in the sensor. So we think we've still got a few issues to work through. We think that this is the issue that we were facing. So in the next race, what we're going to be doing is making sure that we never ever have this issue again. We're going to be moving that sensor off the engine, so it's going to be isolated from any vibration. We're replacing the connector with a new connector, and hopefully that should give us some rock solid results. So ultimately during that race, we ended up doing 3 unscheduled pit stops. So straight away that ended up putting us at about 2 laps behind the lead car in our class. So I'll jump across to my laptop screen again. What we did here is we have to do a driver change. There is a pit window, opens around 15 minutes into the race, closes around 45 minutes through the race. And with our car, we are a little bit limited on our pit window as well for the driver change, because we do need to drop about sort of 30 litres of fuel into the car during the race. So obviously we need to wait till we've got down to a point with fuel burn that we can actually fit 30 litres into the tank. Otherwise we're going to end up running into fuel surge issues as we get low on fuel at the end of the race. So this is our driver change here. Ben's getting out of the car, I'm jumping in. Everything there went pretty smoothly. I headed out and straight away ran into some more fuel surge issues, to the point where coming out of the hairpin just before the pit entry, the car basically cut out and stopped on me. Managed to make it into pit lane. Brandon removed that plug that I just showed you on the fuel pressure sensor, plugged it back in, and for the rest of the race everything was perfect for me. Basically came out of that pit stop though and was straight into a safety car period. So did about 4 or 5 laps of the safety car and basically had a sprint race to the end. We cleared the safety car with about 10 minutes to run, which is around about 5 or 6 laps of racing. So because of my position behind the safety car, with the endurance racing, there is a really wide variety of car speed. In particular, we've got some purpose-built GT3 race cars, the likes of Audi R8s, etc. Obviously incredibly fast cars on this particular track, doing in the region of about 1 minute 35, so a good 10 seconds a lap faster than us. At the same time, there's some very low-powered Hondas, which are much slower, so you're really busy sort of looking out for fast cars that are coming up from behind you, as well as the slow cars that you are coming up to pass. So I'll show you a quick section from in-car. So this is one of the last sort of parts of the race. So it's coming up behind. You can just see it at the moment, just trying to get past them on the left there. This is a Chevy Cruze powered by an LS7. Got squeezed wide there, so came back up behind him. Made the interesting decision here, for those who obviously don't know the track's hard to tell. I decided to go around the right here, got squeezed a little wide again, ran out of track, doing about 140, 150k there. Fortunately, managed to spin back across the track, gather it all up, got it back into second gear, coming out of the exits of the hairpin, and essentially didn't even lose a place. So I was reasonably lucky there. It's not often you get to spin sideways across the track and not get collected by a faster car. Coming up to the Highlands bridge here, I'd sort of regathered everything, coming back up behind the Chevy Cruze, and finally managed to make the pass stick that I was poorly trying to form in that very fast left-hander section. So it turns out I didn't actually learn my lesson though. In the very next lap, I also passed another car around that same spot, although this time managed to keep it on track. So it's all a learning curve. Ultimately, it was a really, really fun race, even if we didn't quite get the results that we were potentially capable of. We ended up with a fourth in class. Although, to put that in perspective, probably not what you're supposed to say, there were only 6 cars in our class. So we know that we had track pace to get a second in class, probably don't quite have the speed for first in class, but yeah, we're looking forward to getting back to our last round. We unfortunately missed the next round because we are at World Time Attack Challenge in Australia, but our last round, which will be Ruapuna in Christchurch in about 4 weeks time. Now, one of the other things I faced when I jumped in the car there, taking over from Ben, is there was a really noticeable clunking when I was on and off power. You don't really notice this too much during racing, but particularly given that I was under a safety car for about 4 or 5 laps there, really becomes obvious when you're in and out of the power. And sort of with a mechanical mind, sort of understanding how the car's put together, I'd pretty much concluded that it was something to do with the diff mounting or the diff bushes. It sounded pretty bad from the driver's seat, and I was actually a little bit worried we were going to get to the end of the race. So that gives us one more thing to fix. It looks like it has damaged the front diff bushes, so we'll probably end up solid mounting that diff. Now, just in terms of some modifications going into the car before our next round. Obviously, I've talked about the fact we're going to move that fuel pressure sensor, make sure that we're never going to face fuel pressure sensor issues again. Want to know that if that fuel pressure sensor is giving us a low pressure warning, that it is real and we can deal with it accordingly. So we're doing that, but we're also going to be adding a raft of new sensors to the car. I just wanted to show you through a couple of them. So we head to our overhead camera here, and this is a Izzy Racing tyre pressure monitoring system. So this little unit here actually goes inside the tyre. It is connected, or attached I should say, to the valve so that it doesn't float around inside your tyre, and the back of this here should end up mounting basically onto the inside of the rim. Now, tyre pressure monitoring systems, not anything particularly new, although they will be new to us. This isn't just any tyre pressure monitoring system though. It might be a little bit hard to see on our overhead camera here, but it also includes a 16-channel infrared temperature array. So that's this little unit here, this little lens that we can see. And what that does is it monitors the internal tyre carcass temperature at the same time as it's monitoring tyre pressure. So it sends all of that information. Obviously, we've got 4 of these on the car. All of that information is sent to this little central receiver. So we'll have a look at that under our overhead camera as well. So this will be mounting in the center of the car, sort of equidistant from all of the wheels. It's got the little aerial for receiving there. And the cool thing with this as well is, if we look at our wiring harness, it is only 4 wires. So as with a lot of the Izzy Racing sensors, it uses a CAN communication bus. So the only wires we've got there are a power and a ground, CAN high and CAN low. So really, really easy to connect and interface with our existing Motec data package, and we'll also be able to monitor that information in the pits. Now, for the driver, this isn't really something that we're going to be looking at. It is useful during qualifying or maybe the first lap of the race to be able to actually monitor your tyre pressures, so you know when you've got your tyres up to the correct pressure. But realistically, under race conditions, you're not going to have time to look at any of that data. What we can do though is monitor this via telemetry from the pits. So we have a technician in the pits making sure that our tyres are doing what they should be doing, particularly if the tyres are over pressured. This gives a heads up on that, and someone can pressure the tyres during the pit stop. But more importantly probably is when you've got a puncture, particularly if you've got a slow puncture. This may not immediately be apparent, and obviously at a high speed course that can potentially be very dangerous as well. So we can set up our dash to give the driver a warning if a tyre is actually going flat, so that as the correct course of action can be taken there, pitting before you end up into a wall. Now at the same time, we're also fitting some Izzy Racing tyre temperature sensors and brake temperature sensors. So again, we'll have a look at these under the overhead camera. Pretty small little unit. Again, these are a 16 channel, so basically they have I think it's a 120 degree field of view, and these can be mounted to the chassis, and basically we get a pattern coming out from those. So we want to mount them far enough away from the tyre that they can monitor the entire tread width. Now, why that's important is because by monitoring the tread temperature across the width of the tread, we can use this data to help us optimize our tyre pressures as well as our camber on the car. So of course the advantage with this over a tyre pyrona being used back in the pits is that it gives us the opportunity to see what's actually happening in real time while the car is out on the track. On top of that, we'll be mounting 4 of those for tyre temperature. We're also going to be monitoring brake temperature with a very similar sensor from Izzy Racing. So pretty excited to get all of that data onto the car, help us to optimize that package, hopefully gain a little bit more lap speed out of the car, and we're going to also be using that for some other course material for our Racecraft project, which is a pretty good time to talk about our Racecraft project. So for those who haven't been keeping up with things, we have been working on a sideline project from High Performance Academy called Racecraft. Very similar to the High Performance Academy in terms of it'll be online training courses, although this time we're basically angling towards optimizing your car's performance on the racetrack. So the first course that we have released literally seconds ago is our motorsport wheel alignment course. So how to perform your own wheel alignments. This course you can find, if we actually head across to my laptop screen, it is right there in front of you at the moment. You can check this out at your leisure if you go to racecraft.hq.com/courses. Right now it's the only course we've got live, but of course we have to start somewhere. So that is available for an introductory price of $129 US, and just like our High Performance Academy courses, you can also use our payment plan, bring it down to just over $16 a week for 8 weeks. We've also got our money back guarantee on this course, so if for any reason you purchase and don't like it, no problem, let us know. You get a full refund of your purchase price. So this is incredibly cheap, particularly if you use that payment plan. $16 a week, it's a couple of cups of coffee or something like that a week, and you've basically covered that. So this is going to be perfect for any enthusiasts out there who are attending track days. It doesn't really matter if you're only doing a couple of track days a year, or maybe you're actually quite competitive, you've got a dedicated race car and you are competing most weekends. And getting lap times out of a car is obviously the aim of the game here. And I see a lot of enthusiasts spending thousands of dollars on performance upgrades to their engine to try and make more power in order to get lap times down. And yeah, of course, that's going to work to a point. The problem is that it's an expensive way of reducing your lap times. It's also putting a lot more stress on all of the components of the car. And the reality is, if you've got a car that's handling like an absolute dog to start with, if you then go and add more power and make the car faster, it's only going to exaggerate those poor handling traits. So my personal preference, my opinion, is that the best place to start when you want to lose lap time is to get your car handling properly. And you can actually be amazed at just how much you can reduce your lap time by getting your suspension dialed in correctly and your alignment specifications set correctly. Now, most enthusiasts, when they are doing this, they're going to end up using the local wheel alignment specialist, maybe at your local tyre shop, to do their alignment. Now, that might work out great, particularly if you have got a factory car straight off the showroom floor. They're probably more than capable of doing that, but the majority of wheel alignment specialists, unfortunately, don't have the knowledge to get the correct alignment specifications to actually suit racetrack use. So in this instance, unless you're very lucky, you've got a specialist wheel alignment guy or girl who does work on a lot of race cars, chances are you're going to be getting subpar results. So the key really here is learning how to do this yourself. And again, most enthusiasts initially think that this is completely out of reach. Obviously, you're not going to have tens of thousands of dollars sitting there to purchase your own camera-based wheel alignment equipment and a 4-post lift to put the car on while you're doing it. But the reality is we can actually do this with some really cost-effective products. And we show you in this course how you can do your own wheel alignments with a DIY camber gauge. Nothing else beyond that more than some aluminium extrusion, some jack stands, some some nylon line and a ruler. Now this probably starts to sound like it's all a little bit backwards and maybe backyardish and cheap. The reality is it couldn't be further from the truth, and if you understand the techniques of doing string wheel alignment, you can get results every bit as good as a commercial camera-based wheel alignment system, often better. And this is the exact same technique that you will see used in the pits at any premium motor race event. This is used right up to and including the likes of LMP1 and Formula 1, so nothing backyardish about it. And having the ability to do this means that with a minimal outlay you can take all of this equipment to the racetrack with you. This is perfect if you want to try optimizing the handling characteristics of your car. Maybe you've got a car that isn't quite handling right in a particular corner and you want to actually start making some minor changes to see if you can get an improvement. Well, this allows you to do exactly that at the racetrack between sessions, and again all for a fairly modest outlay. In this course as well we outlay a 7-step Racecraft process that you can apply to aligning or setting the wheel alignment on any car, and we include a library of worked examples. We've got one in there at the moment following through that 7-step process on our Racecraft Toyota 86. So huge amount of information there. Just like High Performance Academy, purchasing that course will also give you access to our online community. Obviously it's a bit of a ghost town right now. As I said, this course has literally just launched about 10 or 15 minutes ago, so we're going to be building up. We've got some really exciting projects in the line for Racecraft, and as well as some really exciting course material to add to that. So if you are interested, head across. Hopefully the guys can put a link in the comments that you can follow to get involved. Now, on the note of that, I'll just mention really quickly our Racecraft Toyota 86. For those who watched last week, I did mention that we'd had it back on the dyno. We were supposed to be racing there on the weekend after our South Island Endurance Series, which was Friday, Saturday. We had the first round of the Highlands Sprint Series, which is a set of 6-lap races that is held on a shorter track variation at Highlands called ANC. The idea was to run both of the cars. However, once we found the diff problem with the black V8 86, we decided to pull out of that. So Ben went solo in the Racecraft 86. So that's running the turbocharged FA20 engine. We had lent on that just a little bit harder by putting a more freer flowing exhaust on, which resulted in a little bit more boost, and we had about 394 horsepower at the wheels, so probably about 15, maybe 20 horsepower more than we've ever had out of that car before. Tested it during the week and it all went pretty well. However, in Ben's qualifying session, he managed to smash 4th gear, which isn't ideal. That's actually the second time we've damaged 4th gear in that car. So obviously it's trying to tell us something, and we're right now searching out some solutions for that. Obviously we don't want to make any less power. Ideally we'd like to make a lot more power, so we're going to be looking at a gearbox solution that is going to be reliable with a bit more than 400 wheel horsepower. The options we're sort of looking at the moment, we have got an R154 box, which actually came out of the V8 86 when we put our sequential in it. Definitely up to the task in terms of strength, but it's a 5-speed box. It's got a fairly agricultural shift quality, and the ratios are probably not really ideal. It wasn't great behind the V8. It's probably not going to be a whole lot better behind the FA. The other option we're looking at is the T56 gearbox. So again, something that's going to be bulletproof to the power levels we're operating at. The real issue is, and if anyone's got any knowledge that we've overlooked, please let us know. It doesn't seem like there's any easy upgrade options available for those wanting to keep the FA20 in the 86 chassis. And of course, most people, when they're really wanting to make a lot of power from these cars, they jump straight to the top shelf, pull the factory engine out, throw it in the bin, and fit either a 2JZ turbo or an LS. We're suckers for punishment, so we're sticking with the FA. So we're probably going to have to get our hands dirty with a little bit of engineering to make up an adaptive bell housing, but that's a different story for another day. Actually, I have have managed to overlook loading up our YouTube video for today, so I will do that. While I'm doing that, we'll mention we are still running our JE giveaway. So if you are considering building an engine for your project car and you're looking for a set of pistons to go along with that engine build, then this is going to be perfect for you. JE Pistons have teamed up with us. They're supplying any of their off-the-shelf piston kits. So if you've got any popular engine, there's a pretty good chance you're covered there. And along with the pistons, which we will ship anywhere in the world, so it doesn't matter whereabouts you are, we're also going to be including our suite of engine building courses. So this will teach you what to do with those pistons and let you get to put together a nice reliable engine for your project. I'll get the team to drop a link in the comments that you can follow if you want to get your name in the draw, and on top of that, you'll find when you follow that link through, there are a few other tasks that you can do that will give you more entries into the draw. Alright, lastly for today, we'll head across to my laptop, and this is a video we shot while we were in the UK for the Goodwood Festival of Speed, and we had the opportunity to tour Renvale's facility in the UK, and Renvale, probably not a name that a lot of enthusiasts might be familiar with. They tend to keep their head down and a low profile, but they also produce wiring harnesses for just about every top level of motorsport you can think of. In particular, they produce the wiring harnesses for every F1 team with the exception of Williams. They also produce wiring harnesses for LMP1, LMP2, World Rally cars, and just about anything else. So we got a chance to tour their facility and basically go through the process of how a wiring harness is designed, is built, and then is tested in-house before it's shipped out. So if you are interested in looking at that process, finding out what goes into motorsport wiring, then check out that video on our YouTube channel. While you are there, please also make sure you subscribe. I did mention last week we're super stoked as well that we have just ticked over 100,000 subscribers. So thank you to all of you who have subscribed. Hopefully you are enjoying our content, because we're looking forward to punching out a whole lot more in the not too distant future. All right, thanks for watching, team. Give me a moment and we'll get started with today's webinar.